circumference of a circle. How do we find it? It's area. Circumference formula? You guys don't remember how to find circumference? It's not very good, guys. To find circumference, we take 2 times pi times the radius. So 2 pi r is our circumference formula, which technically 2 times your radius is what part of a circle? All right, can we put the phone away, please? It's the diameter, right?
So it's the diameter times pi?
Sure. Could be the same thing as your diameter times pi. So for the circles down here on the bottom, let's find just the circumference.
You forgot the area.
We're doing that tomorrow. Just doing circumference today. So my circumference of this circle, here it's telling me my diameter is 15, so the radius would be what?
15 times pi.
Yeah. My radius would be 7.5, half of it. So on our calculators, I would type in 2 times pi times 7.5.
Excuse me. I lost my calculator, so I don't have one. Does
Which
I have pi?
gets you to 47.12. How do you do units for circumference? Is there anything special about it? Nope, it's just going to be inches. Let's do the second circle. What am I going to do? Circumference is equal to what?
2 times pi.
Good. 2 times pi times 7. So 2 times pi times 7 gets us 43.98. My units are centimeters. All right, so what does this technically mean? What does circumference technically mean?
The area, no, not the area, the distance of a circle, like.
Right, around, right? So if I physically had a circle in front of me that had this being 7 centimeters, I don't know if that's 7 centimeters or not. I could measure it, I guess. What are we at? It's at 17, so it's a little bit bigger. So if I had an actual circle here that this was 7 centimeters long, and I took a piece of, or a measuring tape, or a piece of string, and looped it all the way around the circle, it would go for 43.98 centimeters, right?
But not exactly that, because there's like decimals that go on forever and ever.
Right, I mean it's rounded, it's going to be pretty darn close. So what would be, if we think about this being point A, so from point A all the way back to point A again, would be 43.98. What if I took that arc and cut it in half and made it go to point B? Then what would be the length that I would measure?
Semicircle.
Well, what would be the actual length? What would I do to this?
Half?
I would take half of 43.98, right? So that would get me from point A to point B. What if I put point C up here and went from A to C? What would be the length of that arc? It would be a fourth of this, right? Because that's a quarter of a circle. And there. How many degrees is it from A to C for a quarter of a circle? 90 degrees is a quarter of a circle, right? Yes? What if I made it go, what's half of a quarter to point B? 45 degrees, right? What fraction of the circle would 45 degrees be? 1/8. Good. What if I made point E and made it, what's half of 45? Well, half of 40 is 20, so 22.5. What if I was at 22.5 degrees of a circle? It would be 1/16, right? So whatever your fraction of the circle is, we end up doing what operation between the actual circumference? Half of the circle, what did I do to this? and multiplied it by a half, or divided by 2. A quarter of a circle, what am I doing with the circumference? I'm multiplying it by 1/4. 1/8 of a circle, I'm multiplying it by 1/8. Where do those fractions come from? How many degrees is it from A to B? 180. 180 divided by what number is 1/2? 180 divided by 90 is 2. Huh? Yeah, 360, right? Which, isn't that the whole circle? 90 divided by 360 is a quarter. 45 divided by 360 is 1/8. So this is what's going to be getting us into what we call arc length. So to find arc length, there really is no abbreviation for arc length, but we're just going to use AL. It's not something that's used out in the world, but we're just going to use it. Usually people just write out arc length equals, but we'll be lazy. So your arc length is going to be equal to this formula. We need to find what fraction of the circle it is that I'm looking for. And to find that fraction of the circle, we're going to take your central angle and divide it by 360 to get that fraction, to get that 1/2, to get that 1/4, to get that 1/8. And then we're going to multiply it by what? Well, what did we take that 1/2 and do? Multiplied it by what?
The central angle?
Well, the circumference, which is 2 pi r. Which, remember, that is our circumference of the circle. So what we're technically doing is we're finding a fraction of the whole circumference to find just a specific arc length. Now, keep in mind the difference. Back when we were talking about central angles, if this was, let's say, 110 degrees, how many degrees is the arc? If it's central angle. The central angle is 110. What's the measure of the arc in degrees? The central angle is 110. What's the measure of the arc in degrees? 110. It's the same thing, right? So there's a difference between the measure of the arc, it's going to be a degree answer, and arc length. Arc length is going to be in units, inches, centimeters. I physically put a piece of measuring tape and measured it. That's going to be your arc length. All right, let's go down to the bottom and do these examples. So for the first one, to find your arc length, what's my central angle? 90 degrees divided by 360 times 2 pi. My radius is 6. So on my calculator, I would just do it all in one string because I can. On the TI-30s, you can do it all in one string also. I could just type in 90 divided by 360 times 2 times pi times 6 and hit enter. It's going to get me a number. What are you guys getting for a number? Yep, that's what I'm getting. So my arc length is equal to 9.42. My units are centimeters. So if I took an actual measuring tape and measured it from point A to point B, that arc's length would be 9.42 centimeters. Let's go over here. What's my central angle? 110. So 110 divided by 360 times 2 times pi. My radius is 25. Type it in your calculator. 110 divided by 360 times 2 times pi times 25. Let's make sure we're all getting the same answer. Yeah, so I'm getting 47.9965, which I would round that to 48.0 feet. Make sure we put that .0 there so that we know that we are rounding. Okay? Once you have that, grab yourself a practice space. We're going to do some more challenging problems where we're going to have to work backwards.
Not backwards. Well, why don't you teach us how to do a